Today we're starting Unit 7, and Unit 7 Lesson 1 is on sum or difference of cubes. So sum or difference of cubes is the same formula, but the signs change depending if you're adding or subtracting. So let's take a look at the sum of two cubes. If you have an expression, if you're given an expression like this, a number cubed plus another number cubed, and you are adding those two, that means that the first sign in the factored expression is going to be the same, giving you a plus b as your first factored expression. And then in the second expression, we have a squared minus ab plus b squared. The second sign is going to be the opposite. And lastly, this sign here, that sign never changes, depending, or it doesn't matter if it's sum or difference, it's always addition. If we look at difference of cubes, we start off with a cubed minus b cubed, so a number cubed minus another number cubed. And we factor it to a minus b times a squared plus ab plus b squared. So the notes I wrote on this first one still apply to the second case, or to the difference. If you look right here, the first sign is the same. The second sign is the opposite, and that last sign is always addition. All right, so with this, it's important to know that you need to rewrite every term as a base and an exponent. The reason why you need to do that is so that it fits this here or this here. So it fits either sum of cubes or difference of cubes. So in order to rewrite as a base and an exponent, and knowing that you need to rewrite it with an exponent of 3, it'll be helpful to have a list of perfect cubes. So I'm going to make a short list on the side of my paper. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed, 729. And 10 cubed is 1000. Of course, this list continues, but that's enough for us to get started for the first couple examples. All right, our first example set says to factor the sum or difference of cubes. So the only way that you tell which formula you're using is by the sign. So right here we're adding, so this is going to be the sum of cubes. If we are using the sum of cubes because we have an addition sign, that means we are following this case. All right, before I start, I need to rewrite every term as a base and an exponent. Obviously, this first term is already x cubed, so I'm going to write this as x cubed plus, and then 27, let's look at my list. 27 is 3 cubed, so I can rewrite 27 as 3 cubed. Okay, and now I need to factor it. Factoring is using this. So previously when we factor, we have to find a times c, multiply those, what adds to b, do that whole step. When you're dealing with sum or difference of cubes, you just substitute your values into this formula. so the formula we went over above. Before I start, I'm just going to identify my a and b value. Your a and b value are only the values or only the base of the exponent. So a is x. I'll do b in a different color. B is 3. Not 3 cubed, just 3. It is just the base. And now to factor. Well, using this expression, it says a plus b. So my first part of my factored expression is going to be my a value plus my b value, or x plus 3. The second expression is a squared, x squared, minus a times b, 3 times x, plus b squared, 3 squared. And the only other thing you can do here is you can simplify any terms that need to be multiplied out or simplified. X plus 3 times x squared minus 3x plus 9. This is your factored expression. So basically this whole lesson is just understanding how to substitute into a formula. You're substituting into the sum of cubes or the difference of cubes formula. Okay, next we have x cubed minus 8. We have subtraction, so this is difference of cubes. That means we are following this factoring pattern. Before we start, we need to convert every term to a base and an exponent. Obviously, that first term, x cubed, is already converted, so I'll leave that as x cubed. Minus 8 is the same thing as 2 cubed. From here, my a value is x, and my b value is 2. You do not include the sign. The sign is already included in the formula. So your a and b values should always be positive numbers. And then to factor, the first expression is x minus 2, or a minus b. The second expression is x squared, that's a squared. I'm following this up here if anyone's wondering. So a squared plus ab, so plus 2 times x, and then plus 2 squared, or b squared. The only thing I can do is simplify. X minus 2, x squared, plus 2x, plus 4. All right, so again, all you're doing is substituting into the formula. If you missed the formula that I had circled at the top of the page, and now you can't see it on my screen at this point, I substituted my a and b values into a minus b, this is what's right at the top of your page, multiplied by a squared plus a times b plus b squared. And I used these a and b values. Okay, you use the values that are specific to the problem. All right, and the next one, number 3, we have 125 times x cubed minus 27. So right there we have a subtraction sign. That tells us that we're using difference of cubes. Oops. The first thing that we need to do is convert all terms to a base and an exponent. This one is a little bit more challenging because now we have a number in front of x cubed. You have to change every term to a base and an exponent. So if we have 125, we can rewrite that as 5 cubed times x cubed minus 27, which is 3 cubed. All right, and I am using this list. I know you can't see it on my screen, but I'm using this list that we made of perfect cubes. So the next thing, we need to clean this up. If you have two numbers raised to the same exponent, which you do, both of these values are raised to the power of 3, then you can rewrite this as 5x in parentheses raised to the power of 3, which you absolutely have to do. You cannot skip this step. This step is important because this clearly identifies that your a value is 5x. Your b value is 3. Without doing this step here, you would miss your a value, and you need to make sure you include the whole thing. So if we factor this problem, our first part is a minus b, or 5x minus 3. Our second part is a squared. That would be in parentheses, don't forget the parentheses, 5x squared plus a times b, which is 5x times 3, plus b squared, which is 3 squared. So now we just clean up anything we can, which we can clean up this expression, and we can clean up this expression, and this one. So we have 5x cubed multiplied by 5x squared is the same thing as 25x squared. It's 5 squared times x squared. So 25x squared plus 5x times 3, which is 5 times 3, or 15x, plus 3 squared, which is 9. And this is your final answer. Okay, so to recap, you identify if you're starting with an addition or a subtraction sign, and then that identifies whether or not you're dealing with sum of cubes or difference of cubes. And then you substitute it into the formula that's written at the top of the page. Last step is to simplify. Make sure you always start with numbers that are a base and an exponent of 3. Okay, for this on your own section, I want you guys to try to complete this by yourself, and that's what I'll go over towards the end of class if you want to log on to the live session. I wrote a note on here, and you really need to, because, like, for example, number 4, you need to check for a GCF or a common factor. You need to see if you can take anything out. So, for example, number 4, you could take a value of 2 out. You have to, or else you can't even factor this. All right, so make sure you always check for your GCF before you finish factoring. My answer key is posted under the note sheet, and like I said, I will be reviewing this during the live session at the end of class.